All right, so let's talk about piecewise functions. Piecewise functions are always kind of fun, I think, because they're like a puzzle. We kind of put everything together that we already know about graphing and, basic translations, and we just take pieces of individual functions to form one function. It's a really useful skill when we talk about modeling different things, as not everything just obeys, the pattern of one function. All right, so let's start with an example. So I am choosing an example that is like problem type 3 in your ALEKS homework. So this would be a good one to take a look at, before you try that topic. It's the more advanced topic, as some of the other piecewise function topics prior to this one, I think, are a little bit easier, and you could probably understand by looking at the explanations in ALEKS. But let's take a look at one of these that is a little bit more involved. All right, so we're going to look at x squared plus 1 if x is less than 1, 2 if x is equal to 1, and 7 minus 5x if x is greater than 1. And we're going to graph this. So we have three different functions, and we're going to look at pieces of each of these functions. And so we should already know what the graphs of each of these things look like. This is an x squared function, so we know that this is going to be a parabola. This is a constant function, so we know the graph is a horizontal line. And this is a linear function, a degree 1 polynomial with slope of -5 and y-intercept of 7, if we think of that y equals mx plus b form. So I know the graph of this is going to be a line. So let's think about what each of these pieces are going to look like and where. So I think it's helpful sometimes to just graph all three and then think about where you want to shade them in. And I would use the bounds here, the x is less than 1, equal to 1, greater than 1, to help you pick points to plot. So since I'm looking at really y equals x squared plus 1, but I'm just going to look at the piece of that graph for values of x smaller than 1. So I know that x squared plus 1 is a parabola, right? It's going to open up, and it's going to be shifted up 1. So I know the basic shape of this. But it's going to be nice to know what the exact point is when x equals 1, because that's like a cut point for me. So when x equals 1, y is 1 squared plus 1, or y equals 2. So that tells me that the point 1, 2 is on the graph of x squared plus 1. So that would be 1, 1, 2 would be about here. And then if I want to think of the other side, I know there's symmetry in a parabola. I also know then that when x equals -1, right, y would be a -1 squared plus 1, also giving me 2. So I know that that point -1, 2 is also on the graph. So I'm just sketching x squared plus 1 kind of outside the context of my piecewise function. I know it would look something like that. But now I just want to shade in values that are smaller than, strictly smaller than 1. So if this is 1, I go up to the graph, I would actually make an open circle and then just shade in my parabola to the left. So I don't need this piece of it. That is the only piece that I'm going to use. So I'm just going to remake my open circle. There we go. Okay, so I've got that piece of the parabola for all values of x, to the left of 1. All right, so it looks like f of x equals 2, or we're considering the line y equals 2 as a function that we're going to just take a piece of. So yeah, that is a horizontal line. So y equals 2 is a horizontal line that goes through 2 on the y-axis. I'm just concerned with a piece of that function when x equals 1. So for all x values, y equals 2. So again, when x equals 1, y equals 2. So 1, 2 basically just tells me that I'm going to now fill in this hole using that piece, and I can disregard every other part of that function. And now finally, with y equals 7 minus 5x. So like I said, you can really think of that as y equals mx plus b form is negative 5x plus 7. We have a slope of negative 5 and a y-intercept of 7. And I just want the piece for values of x larger than 1. So I just want the piece that's to the right of 1. So what's useful here is I know I'm going to have a negative slope, so I know I'm going to have a line that is falling from left to right. And really, 2 points determine a line, so I just need 2 points on this line. So again, knowing exactly what it's doing at 1 is helpful, so I know where to start that piece of the graph. So when x equals 1, if I'm looking at y equals negative x, or 5x plus 7, so this would be negative 5 plus 7, or 2. So that tells me 1, 2 is on the graph. Okay, so we actually already have that point. And now I want another point to the right of 1. So really we could pick anything. I'm just going to grab 3. So y equals negative 5 times 3 plus 7. So this would be negative 15 plus 7, or negative 8, telling me that the point 3, negative 8 is on the graph. So again, consistent with what I'm thinking, because I know that this line is going to fall from left to right. So that would give me another point. So that line, again, we just want this piece of it. Let's see how straight I can draw a line freehand. Close. Is going to look something like that. So that's the graph of our piecewise function. So other good things that are to talk about are, what is the domain? So we're looking at the x values. Do we use all of the x values on the x-axis? Does every x value get mapped to a y value? And the answer is yes. So the domain would be all real numbers in this case, as would the range, right? If I'm considering all of these y values, we have y values for this whole function from negative infinity to positive infinity. And then we can talk about continuity. So is this function continuous? And continuity can be a tricky continuous subject. For our purposes, we're considering the domain of all real numbers. So we're considering this whole thing. And basically, one way to look at it, as far as we're concerned right now, is in order to trace the graph, do I ever have to lift up my pencil? And in this case, the answer is no. So this is also continuous, for all real numbers. Other questions you might see with respect to some of the other topics in the piecewise functions is you could be asked to find a specific value. Like given this piecewise function f of x, maybe find f of negative 2. And so you just want to keep your eye on the bounds. So which of these 3 does negative 2 fit in? Since negative 2 is less than 1, we would plug negative 2 in for x on that first function. So negative 2 squared plus 1 would be 4 plus 1 or 5. So f of negative 2 is 5. If I was looking for something like, f of 5, then I would plug it in down here since 5 is larger than 1. So we would say, okay, 7 minus 5 times 5, or 7 minus 25, and get that value. So that's it for the most part with piecewise functions. Give them a try and certainly let me know if you have any questions.